Picture a modern supermarket to your left. Chicken breasts, pork chops, lamb, marbled beef, shelf after shelf. To your right, almost nothing. No wolf steaks, no lion burgers, no tiger fillets. And it's not because we lack the technology to hunt them. We have rifles, traps, aircraft, satellites. We could kill almost anything on this planet. So why did civilization build itself around animals that graze and flee, while the great hunters almost never became livestock? The answer isn't simply, predators are dangerous. Danger is only the opening chapter. The real story is about energy, risk, and evolution, and once you see it, the supermarket stops looking like a collection of food and starts looking like a map of the rules that govern life itself. Welcome back to Explain Matics. Humans domesticated cattle, sheep, goats, pigs, chickens, camels. Animals we could breed, control, and convert into reliable food. We never built wolf farms or lion ranches on anything remotely resembling that scale. Was that just culture? Or were our ancestors, without knowing any ecology, discovering the same mathematical truth over and over again? In 1942, ecologist Raymond Lindemann reshaped how scientists understood energy moving through ecosystems. Plants capture sunlight. An herbivore eats the plant. A predator eats the herbivore. But energy doesn't move upward cleanly. At every step, most of it is lost to metabolism, movement, and heat. Ecologists often cite roughly 10% as a rough transfer rate between trophic levels. The exact number varies enormously, but the underlying pattern remains. Asterisk, energy generally becomes less available as you move upward through a food web. Imagine a field of grass. A rabbit eats the grass. A fox eats the rabbit. If you eat the grass, you take energy straight from the source. If you eat the rabbit, some energy is already gone. If you eat the fox, most of it is gone before it ever reaches you. Energy loss is one reason predators generally occur at lower population densities than the herbivores beneath them, though territory, reproduction rate, and prey availability shape that too. Either way, the ecosystem simply can't fund that many hunters. Now try to farm the fox instead of the rabbit. The fox needs meat. That meat needs to come from somewhere. So, instead of using your land to grow food for yourself, you're using it to grow food, to feed an animal that you'll eventually eat. You've added a middleman, and every middleman takes a cut. That's reason one, predators make terrible livestock. Asterisk, they're too expensive to feed. A lion can't live on grass. A wolf can't live on hay. Their biology is built to extract energy from other animals, which means every kilogram of predator meat already passed through at least one extra mouth before it reached yours. There's a second problem. Predators need territory. They compete, and many reproduce slowly. You can breed 10,000 sheep in a field. Try that with 10,000 wolves. You'd first need to farm everything the wolves eat, then contain animals whose entire biology is built around hunting and killing. The economics collapse before you start. Our ancestors never did the math, but the archaeological record shows they found the answer anyway. At Olduvai Gorge and Koubi Fora, evidence of butchery on herbivore bones dates back roughly 1.5 to 2 million years. Site after site shows early humans built their diets around antelope, deer, horses, and cattle-like animals, not lions. But the rule was never absolute. In Germany, researchers found evidence that Neanderthals killed and butchered a cave lion nearly 48,000 years ago. So humans clearly can, and sometimes did, eat predators. Which means the real question isn't, why did humans never eat predators? It's asterisk, why predators never became the foundation of human food production. Say you ignore the economics and hunt the predator anyway. You butcher it, you cook it. It looks like any other meat until you get to one organ, the liver. In December 1912, explorer Douglas Mawson was crossing Antarctica with Belgrave Ninnis and Xavier Mertz when Ninnis fell into a crevasse, taking most of their food with him. Stranded, the two survivors began eating their sled dogs, including the livers. Both men fell ill, but Mertz's condition deteriorated far more severely and rapidly. He suffered hair loss, skin peeling, and severe neurological symptoms before dying in January 1913. Mawson also grew sick and weak, shedding skin and hair of his own, but survived and eventually walked back to safety alone. Modern medicine strongly links Mertz's death to hypervitaminosis A, vitamin A poisoning, Vitamin A is essential, but the liver stores it, and in some Arctic predators, those stores become extraordinarily concentrated. Polar bear liver is the textbook case. It can contain enough preformed vitamin A that even a relatively small serving may cause severe poisoning. Similar poisoning has been recorded after people ate the livers of large predatory fish. The lesson isn't that predator meat is cursed, it's that certain organs, in certain species, concentrate nutrients to dangerous levels. A risk ordinary livestock simply doesn't carry to the same degree. There's a second, quieter danger, and it lives in the ocean. A tiny organism absorbs a trace contaminant. A small fish eats thousands of them. A bigger fish eats hundreds of small fish. A predator eats the bigger fish. At successive trophic levels, certain substances don't just persist, they become increasingly concentrated, especially in large, long-lived predators. This is biomagnification, and mercury is its most famous example. In water, mercury converts into methylmercury, which fish absorb both from their environment and their prey. The bigger and longer lived the fish, the more it accumulates. That's why the seafood aisle has an invisible hierarchy: sardines, then salmon, then tuna, then shark and swordfish. Current FDA guidance places shark, swordfish, marlin, king mackerel, and big A tuna in the highest mercury category for pregnant women and young children, while salmon, sardines, and canned light tuna sit near the bottom. Humans didn't avoid predators entirely. We learned, slowly and sometimes fatally, that not all predators are equally safe to eat. Slice open a wild carnivore, and you're not just handling muscle, you're handling an animal that spent its life eating other animals, some of which may have been infected. Trichinella is the classic example. Microscopic parasites that infect humans through raw or undercooked meat. Bears carry them. Cougars have caused outbreaks. Once ingested, the larvae migrate through the body and embed in muscle, causing fever, pain, and in severe cases, cardiac or neurological damage. Modern antiparasitic treatment can be effective, especially when the infection is caught early, but before refrigeration, thermometers, and antiparasitic drugs, it was a different game entirely. This risk isn't exclusive to predators. Herbivores and livestock carry pathogens too. But wild carnivores encounter a wider range of prey, carcasses, and diseases over their lifetimes, which raise the uncertainty for anyone eating them. Everything so far, the energy cost, the toxic livers, the parasites, explains why predators are risky and expensive, but none of it on its own explains domestication. Humans have tamed genuinely dangerous animals before. So why did cattle, sheep, goats, pigs, and chickens become the foundation of agriculture, and not wolves or lions? This is really the heart of the question. Domestication was never just about whether an animal could be killed or controlled in the wild for a single hunt. It was about whether an animal could live alongside humans, generation after generation, productively. That test has several parts, and predators fail almost all of them. Can you feed it cheaply? A cow eats grass, something humans can't even digest, and turns it into meat and milk. A wolf or a lion needs meat, which means someone still has to raise or hunt the prey underneath it. Can you breed it reliably on a schedule in captivity? Cattle, sheep, and pigs reproduce predictably and mature fast. Large predators tend to reproduce slowly and need far more space per animal. Does it tolerate confinement without stress or aggression? A wild wolf doesn't naturally treat a fence as shelter. Its instincts are built around territory, movement, and hunting, not settling down inside a pen. Does it have a social structure humans can exploit, like a herd hierarchy we can step into as the leader? And critically, does keeping it alive return more food than it costs to maintain? A lion fails that last test decisively. Raising 10,000 lions means first raising, or capturing, enough prey to feed 10,000 lions, which means you're spending land, water, and labor to produce food for an animal that is itself supposed to become food. At that point, the obvious move is to skip the middle step and just eat the prey directly. That's the real engine behind agriculture. Not that humans refuse to eat predators, but that keeping herbivores was simply a better return on investment, generation after generation. Where it made ecological and economic sense, we built our food systems around animals lower on the food web. We turned grass into cattle, grain into chickens, and plants into pigs. And that shortcut through the food chain is what eventually scaled into civilization. Humans have a powerful disgust response to rot, decay, and contamination, and it makes evolutionary sense. But there's no evidence of a dedicated instinct that says predator meat equals disgusting. Cultures worldwide have eaten crocodile, shark, and other carnivorous animals without hesitation. Our ancestors even hunted the occasional cave lion. What looks like instinct today is really a blend of biology, culture, and thousands of years of trial and error. If a food kept making people sick, they stopped eating it. If an animal was too costly to raise, they invested elsewhere. Those choices calcified into tradition, tradition into culture, culture into agriculture, and agriculture into civilization. And yet the ocean breaks the rule. Tuna, a genuine predator, became one of the most important fisheries on Earth. Why? Because marine food webs are structured differently. Phytoplankton provide the energy foundation for enormous marine food webs. And that energy flows upward through several layers before reaching predators like tuna, allowing humans to harvest near the top without personally raising every level beneath it. But the bill still comes due. Trophic position still matters. Mercury still climbs the chain. That's why modern seafood guidance doesn't just say fish is healthy. It asks which fish, how large, how long lived, and how often you're eating it. Humans didn't stop eating predators because they're inherently poisonous, and we didn't develop some universal hatred of carnivores. We discovered something more practical. Predators are expensive to raise, hard to control, often scarce, and sometimes carry extra risk from parasites or accumulated toxins, while herbivores turn grass, something we can't even digest, into meat, milk, and labor. We didn't outcompete the food chain by becoming the strongest animal on it. We beat it by learning to manage energy, growing the grass, protecting the herd, breeding the animal, replacing the hunt with production. That's why your supermarket looks the way it does. The empty shelf where lion meat should be isn't an accident. It's the visible result of millions of years of ecology and thousands of years of human trial and error boiled down to one rule. Asterisk, the most powerful animal on the menu is rarely the smartest one to eat. But there's an irony here. For thousands of years, humans moved away from predators because climbing the food chain was too expensive. Today, sonar, freezer ships, and global trade let us climb it again, hauling predators out of oceans that once made them untouchable. So the question isn't, can humans eat predators? Clearly we can. The real question is, how many can the planet afford to lose? Predators aren't just food, they're part of the machinery holding ecosystems together, and removing enough of them sends consequences rippling down through everything beneath. Our ancestors learned the cost of that food chain through hunger and sometimes death. We're relearning it now through science and discovering that the natural food web was never something humanity could control at every level without consequences. And that's not even the darkest chapter. When famine wiped out the normal food supply, humans crossed lines that would be unthinkable today. Foods so taboo they nearly vanished from history the moment the crisis passed. Asterisk, if you want to see the darkest survival diets in human history, watch the next video.